Okay. May June 2020 paper 3 variant 1. Question 1. A student measures the length of the coil using a ruler. His measurement is 3.8 centimeters. There are 20 turns of wire in the coil. 20 turns of wire in the coil. The student uses his measurement to calculate the average thickness of the wire. Show that the average thickness of the wire is about 0.2 centimeters. Show that the average thickness of the wire is about 0.2 centimeters. So what should we do? So all we need to do is divide the total length by the number of coils, صح? By the number of turns. So 3.8 divided by 20. 3.8 divided by 20 is what it is, about 0.19 centimeters, which is very close to 0.20. Okay, which is very close. So 0.19 is around 0.2, 0.20. The student measurement, okay, the measurement is inaccurate. His measurement of 3.8 centimeters is inaccurate. Suggest one reason why this measurement may not be accurate. Why his measurement of 3.8 centimeters might not be very accurate. Um, okay. Someone saying the parallax error, which is a really, really nice answer. Okay, perpendicularly, this is a really, really nice answer. This is actually more of a paper six answer than it is a paper three answer. The reading, the parallax error might be more of a reading. More of a paper six answer. He did not start from zero. Yes, that's a more practical answer for paper three. Again, this is a more practical answer for paper 3. Okay, someone else is saying the space between the coil. Yes, we can find these very small spaces between these coils, which might give an inaccuracy. Yes, these are all correct answers. But as for perpendicular reading or the parallax error, it could be a correct answer. I'm not saying it's wrong, but it's more of a paper six answer rather than a paper three answer. So it didn't start from zero. Okay, this sounds quite easy. Okay, didn't start from zero. These small spaces, okay, these small spaces between the coils, small spaces between the coils could affect the reading. Yes. The volume of the wire is 16.6 centimeters cubed and the mass is 148 grams. Calculate the density of the metal used for the wire. Can I find the density? Yes, density equals mass over volume. Mass over volume. So mass is, yeah, density equals mass over volume. Basically 148 divided by 16.6. 48 divided by 16.6, which is around 8.9 grams per centimeter cubed. Yeah. Next question. The student has a measuring cylinder and a beaker of water as shown. Describe how the student can determine the volume of the coil using the equipment shown in figure 1.2. So we have a measuring cylinder, some water, and the coil. All we need to do is what? Add some water to the measuring cylinder. Add water, add water, water. Yeah. Add water to the, I'm just gonna write MC. You know, MC stands for measuring cylinder. Okay, and take volume one. Take the reading. And take the reading of volume one. Okay, and then add the coil to the water. Add the coil to the measuring cylinder again, and take the reading of what? Of V2, volume 2. To find the volume, he's only asking about the volume. He's not asking about the density. Okay, to find the volume, okay, volume of the coil would be equal to what? V2 minus V1. This is the volume of the coil. V2 minus V1. Okay, add water V1. Add the coil V2. V2 minus V1 is the is the volume of the coil. Hmm. Question 2. A student stretches a spring by adding different loads to it. She measures the length of the spring for each load. The length of the spring for each load. Okay, not the extension. She's measuring the length of the spring. What is the length of the spring without a load? Without any load, the length of the spring would be at this point, which is 6 centimeters. Okay, can I find the length of the spring with a load of 4 newtons? Yes, at 4 newtons, you need to draw a line. Okay, and you need to be as accurate as possible. Okay, if you draw the line, okay, if you draw the line would reach this point, which is in the center of this square. If you draw another horizontal line, it will reach this point exactly. No, it's not 12.5. This is not 12.5. Why? Because this is between 12 and what? It's between 12 and 14. It's between 12 and 14. Between 12 and 14 is 13. Between 12 and 14 is what is 13. So again, this is between 12 and 14, not 12 and 13. If it was between 12 and 13, it would have been 12.5. But for this question, it's between 12 and 14, so it is actually 13. So the answer, the length is now 13. If you add 4 newtons, the length would be 13 centimeters. What is the extension due to a 4 Newton load? What is the extension due to a 4 Newton load? The extension would be simply L minus L naught. The length, extended length, minus the original length, which is 13 minus 6. صح? 13 minus 6 is what is 7 centimeters. صح? 7 centimeters. Okay. Stretching a spring with a load is an example of how force can change the what and what of an object. Uh, can change two things, can change two properties of an object. It can change the size and shape. Yes, the size and the shape of an object. You can say size and the shape of this object. Okay, some gas molecules are in a box at room temperature. Describe the movement of these gas molecules. Yeah. The movement of gas molecules is what? Fast and random in all directions. Fast and random in all directions. Fast and random in all directions. Describe how the molecules exert a pressure on the walls of the box. How do they exert pressure? Well, as they're moving fast and random, what do? They hit the walls. They collide with the walls. They hit the walls. As they hit the walls, what do? Exerting a force. Okay. Okay. Yeah, exerting a force over an area. Over an area. Yeah, the force over an area is pressure over an area, which is pressure. Yeah, hit the walls, exerting a force over an area which is pressure. The gas in figure 3.1 is cooled. Okay, it is cooled. The gas turns into a liquid and then to a solid state. How the average separation of the gas molecules is different from the average separation in a solid. And the gas is different from a solid. Separation. We need to talk about the separation. In the gas, they are very far away, but in the solid, they are touching. صح? In the gas, very far apart. In the solid, very close. You can say they are touching. You can say closely packed. صح? Closely packed. Okay, we're talking about the separation only. Can I find the average speed? Yes, average speed equals total distance over total time. Average speed equals total distance over total time. What's the total distance in this question? 200. What is the total time? 6.4. 200 divided by 6.4 is around 31 meters per second. 31 meters per second. We have a speed time graph for a skier in another part of the race. Describe the motion of the skier at points P, Q, R, and S. 4 points, 4 different points. What's happening at P? What is happening at P? His speed. What's happening to his speed? This is a speed time graph. What is happening to the speed? The speed is increasing. He is accelerating. Constant acceleration. Yes, excellent. Okay. He has a constant acceleration. Excellent. What about in Q? What's happening? Constant, yes, speed. Thank you. Constant speed of what? Of 17.5 meters per second. If you want to write down the speed. Okay, so this is a constant speed. طيب. Accelerating in P. Yes, in P you can write accelerating. In P you can write accelerating. Q you cannot write down it's accelerating. Why? Because it's moving with a constant speed, zero acceleration. R, what's happening in R? Non-uniform deceleration. Excellent. Yes, non-uniform deceleration. Non-uniform deceleration. Okay. طيب, what if I wrote down in P increasing speed? Yes, in P you can write down increasing speed. More accurately, you can write down acceleration. Okay. Constant acceleration of what? Constant acceleration of the speed. The speed is increasing constantly because because it's a straight line. Okay. Constant acceleration. Q constant speed. Do we have to in R? Do I have to write down non-uniform? No, you're not. Yeah, you don't have to write down non-uniform. You do not have to write down non-uniform. You can just write down that it's decelerating or that the speed is decreasing. The speed is decreasing. What about S? Huh? S he someone saying ununiform is correct. Um, Ununiform. It's it's not wrong, but in English there's nothing called ununiform. Okay. S is stationary. Yes, it's at rest. It doesn't move. Okay. At rest. Yeah. حلو. Skis are strapped to a skier's feet and are no longer, sorry, are longer and wider. They are longer and wider than the skier's feet. How does this prevent him from sinking into soft snow? Why do we increase the length of the ski? Why do we increase the area of the base of this ski? How does this prevent him from how does this prevent him from sinking as you increase the surface area? What happens to the pressure? Pressure decreases, صح? So as area increases, what happens to the pressure? Pressure decreases. Yeah, pressure. They are both inversely proportional. Do I have to write it down? If you want to, you can write it down. Pressure decreases as area increases. Okay. لا, pressure decreases as the area increases. Pressure decreases inversely proportional. Okay, inversely proportional. Okay, that's why he doesn't sink. If the area increases, he would have sank. So he would have sunk مش عارف يعني. Anyway, a meter ruler is balanced on a pivot by three vertical forces. Three vertical forces. Okay, this is a new question. Not a new question, but a bit more, slightly more difficult. Show that the moment of the 5 Newton force about the pivot is 200 Newton centimeters. The moment of the 5 Newton. How can I find the moment? Moment equals force times perpendicular distance. What's the force? 5 Newtons. And what is the distance to the pivot? The distance to the pivot is 40 centimeters. So this gives you a total of 200 Newtons dot centimeters. Okay, this is easy. Calculate the size of force F. Can I find the size of force F? Yes, I can find the size of force F. How can I find the size of force F? Huh? It's using what? Clockwise moment is equal to anti-clockwise moment. Why? Because it's in equilibrium. It is balanced. Huh? It is balanced. Type. How can we find the force F? 4 marks. 4 marks. First of all, we need to write down what? First of all, you need to write down clockwise moment is equal to the anti-clockwise moment. Clockwise moment is equal to the anti-clockwise moment. Which of these forces, okay, we have 3 forces. Which of them is clockwise or which of them exerts a clockwise moment and which of them exerts an anti-clockwise moment? The 5 Newton force. So how can I differentiate? How can you differentiate between clockwise and anti-clockwise? All you need to do is what they show. Take the force or draw an arrow from the force to the pivot. Draw the arrow with the direction of the force to the pivot. This arrow is directed downwards, so I'll draw an arrow to the pivot. Is this clockwise or anti-clockwise? No, this is anti-clockwise. What about the weight? Let me draw an arrow from the weight all the way to the pivot. And this is clockwise. This is a clockwise moment. الفورce to the pivot. This is also clockwise. This is also clockwise. So now we have 2 clockwise moments and only 1 anti-clockwise moment. Anti-clockwise moment we calculated it, which is 5 times 40. So 2 clockwise moments, force times distance, perpendicular distance, plus another force times another perpendicular distance should be equal to the anti-clockwise moment, which is 5 times 40, which is again force times perpendicular distance. So let's write them down. Let's write them down. First, the first clockwise moment, which is the F. First clockwise moment, which is the F. F, I don't know what's the force. F times the distance to the pivot. What's the distance between this force and the pivot? What is the perpendicular distance between this force and the pivot? It's the distance from this point all the way to this point. No, it's not 50. It is not 50. It's actually 60. Why is it 60? Because this distance, no, it is 50. صح? 50 all the way to the center. And then there is an extra 10 centimeters from the center of mass to the pivot. So the total distance is what? The total distance is 60. Or you can say, yes, you can say 100 minus 40. Excellent. You can say 100 minus 40. So F times 60. Okay, this is the first clockwise moment plus the second clockwise moment, which is 2 times 10, which is 2 times 10 equals, يلا احنا we calculated it 5 times 40, which is 200. F times 60, F times 60 plus 20 equals 200. Okay, if someone decides to add 60 and 20, honestly, I don't know what to say to them. Honestly, if you decide to add 20 plus 60 and say F times 20, I honestly have no words for you. I have nothing to say. Okay? Because I've seen it before. I've seen it before, and honestly, I don't know what to say. No, you wouldn't add, you can never add the 20 plus the 60. You need to minus 20 minus 20, 200 minus 20, which is 80, 180. So F times 60 is equal to 180. Then divide by 60. If you divide 180 by 60, this would give you a final answer of 3 newtons. This is simple math. Okay, if you do not know how to use these operations, then you need to revise your math. Okay, you need to revise your math. Okay, that's all you need to do. First of all, 200 minus 20, which is 180, and then you divide by 60. Never, ever, ever, ever add 60 plus 20. This would be completely wrong. Okay. Um, someone saying, can I just subtract 5 minus 2, which would be 3? No, that's 100% wrong. That is 100% wrong. Okay. Clockwise force is 2 and anti-clockwise is 5. No, that is wrong. Again, انت what you're saying is clockwise moment is 5. No, the clockwise moment isn't 5. Okay, clockwise moment isn't 5. This is a force. Okay, this is a force, and it's pure luck. It is pure luck that 5 and 2 and 3 add up. 2 plus 3 is 5. This is pure luck. Okay, if this 2 Newton force was, for example, 3 newtons, or if it was 4 newtons, it would have been completely different. It would have been completely different. So please do not use luck while trying to solve these questions. Okay, we don't use luck. We use mathematical equations. Thermometers have been removed from the syllabus. Thermometers have been removed from the syllabus, but we can solve some of this part of this question. Okay, we can solve part of this question. First of all, he's asking about the unit for measuring the temperature. What is the unit for measuring the temperature? The unit is degrees Celsius or Celsius. Okay, degrees Celsius. And on this thermometer, you have a point which is labeled the ice point at 0 degrees. At 0 degrees. Can I label the steam point? Can I label the steam point, which is basically the boiling point? Can I label the boiling point? Yes, it's at 100. It is at 100. The steam point. Okay, it's at 100 degrees Celsius, the boiling point of water. Okay. Part B, you're not required to solve part B, so we can just cancel out part B. We can cancel out part B. Hmm. Hmm. Okay. Part C, a student is testing how different surfaces absorb heat. Okay. How different surfaces absorb heat. A metal disc. Okay. We have two metal plates on either side. One of them is shiny white and the other is dull black. And we have some wax, okay, attached, metal disc is attached to the plate using wax. We have a metal disc which is attached to each plate using what? Using wax. The student turns on the radiant heater and the stop clock. Okay, 53 seconds. The wax on the plate with dull black surface after it melts after 53 seconds. The metal disc on the plate with a shiny metal remains attached for another 32 seconds. Explain why. Okay, explain why. Okay, why did this happen? Okay, why did this happen? Because simply all you need to say is that the black surface, okay, is a better absorber, okay. A black surface is a better absorber of infrared radiation, okay. So the temperature rises faster. A black surface is a better absorber of infrared radiation so temperature increases faster. Temperature increases faster. Another student observes the experiment shown and says that the comparison, okay, that the comparison of the two plates is not fair. Suggest, okay, um, yeah. What does the question want? What does this question in I? What does the question want? The question, he just wants to know why did the wax on the metal plate, on the black surfaced metal plate, melt faster? Okay, he said that the metal plate melted after 53 seconds, and then the white surface waited for another, okay, it remained attached for another 32 seconds, and then it melted off. So why is that so? Because the black surfaces are better absorbers, okay, the better absorbers of infrared radiation. That's why the temperature increases faster. And double I suggest why the experiment is not fair. Yes, exactly. Thank you. All of you said it correctly because the distances aren't the same. The distances aren't the same. The distances need to be the same. Okay? The distances need to be the same. So in this question, he had 8 centimeters and 10 centimeters. No, the distances, okay, must be the same. You need to have constants, okay? Distances must be The same. Okay. Um, Controlled variables, as we say in paper six, they are the controlled variables. Okay. Yeah. Moving on to the next question. Why 2 marks? Because you need to state controlled variables and the distances are equal. You need to state that. In question 7, determine the angle of incidence from the ray. The angle of incidence, it's 30 degrees. Is that correct? No, definitely that's wrong. That is definitely wrong. Why is it? Uh, 50? How did you get 50? No, it's 60. How do I get 60? Because you have the normal line. This is the normal line. And all you need to do is 90 minus 30 degrees. Okay, 90 minus 30 degrees, which is 60 degrees. It's as simple as that. I need to find the complementary angle for this 30 degrees. Can I draw the normal? Yes, you need to draw the normal perpendicularly. And then draw the reflected ray. The reflected ray should be at an angle of 60 degrees. Okay, this is the reflected ray, which is at an angle of reflection of 60. Angle of incidence equals angle of reflection in mirrors. Angle of incidence equals a angle of reflection in mirrors. Okay, two rays from the tip B, okay, of the object are incident on the lens. Can I continue these rays? Yes, I can simply continue these rays. First ray was moving parallel to the principal axis. It was moving parallel to the principal axis. I think it's 32 because it was at point P. No, 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 no. Angle of reflection. This question will be 60. It can never be 30. Why? Because the angle of incidence is 60, so the angle of incidence, the angle of reflection is also 60. Okay, 60 and 60. There is no other correct answer. You cannot think of any other correct answer or any other close answer, for example. Okay. Hmm. In this question, can I draw the remaining rays? Yes, I can draw the remaining rays. First of all, this parallel ray should refract and pass through the principal focus. It should refract and pass through this principal focus this way and continue in a straight line. And then the ray which was passing through the principal focus, as it reaches the center of the lens, it will move it will move parallel. It will move parallel. So this is the ray. Definitely you're using your ruler. If you don't use your ruler, okay, if you do not use your ruler, then it would be a wrong answer. And the image would appear on this side. So this is the image. How do I know this image? Can I state three properties of this image? Yes, I can state three properties of this image. First of all, it's inverted. It is inverted. It is real. Okay, it's real. And for this image, we will say it's diminished. Okay, diminished, or you can say smaller. Why is it smaller? Because using a ruler, you will measure the object. You'll find that the object is much larger than this image I. This image I is much smaller than the object, so you'll say that it is diminished or smaller. Okay? ماشي. Inverted, real, and diminished. Inverted, real, and diminished. Okay, yep. Moving on to question 8. What is the wavelength of this wave? That's easy. Wavelength is 20. Is that correct? No, definitely wrong. No, definitely it is wrong. The wavelength is 40. Uh, it is 40. Okay, so this is the wavelength. Is there a case when it becomes bigger instead? Oh, yes. Someone's asking for the previous question. Is there a case where it becomes bigger? Yes, if the object is closer to the lens. When the object gets closer to the lens, the image gets larger. The image gets larger. On figure 8.1, draw a wave representing a louder sound with the same wavelength. Louder sound with the same wavelength. How can I draw a louder sound? Simply, you need to increase the amplitude, but the same wavelength, so it will pass by 20 and it will pass by 40. Okay? higher amplitude. State the range of audible frequencies for healthy human ears. يلا. Audible frequencies are from 20 hertz to 20,000 hertz. Can I write down 20 kilohertz? Yes, you can write down 20 kilohertz. Okay, do not don't just write down the numbers. Don't just write down from 20 to 20,000. Okay, you'd lose a mark. You need to include the unit, which is hertz frequency. Okay. Okay, yeah, on figure 9.1, draw the letters N and S to indicate the north and south poles of the magnet. N and S. N would be on the left hand side and S is on the right hand side. Okay, N is on the left hand side and S is on the right hand side. No, you are required to memorize 20 hertz to 20,000 hertz. You are required to memorize it. I never said you're not required to memorize it. You are required to memorize the range of audible frequencies. Okay, S to N. No, if you write S on the left hand side and N on the right hand side, it would be wrong. Why? Because from the North Pole, okay, you'd have the arrows going outwards from the North Pole and inwards into the South Pole. Inwards into the South Pole. Okay. Um, Question part II. State and explain what happens to the soft iron bar you may draw on figure 9.1. If this is the magnet which is brought closer to the soft iron bar, you had, for example, N and S. So what would happen to the soft iron bar? The soft iron bar would become a magnet. It would become a magnet. So, for example, this part will be north and this is south. How can we explain it? How can we explain it? The iron bar is now attracted to the permanent magnet. Okay, it is attracted to the permanent magnet. It becomes a new magnet. It becomes a temporary magnet with opposite poles. With opposite poles. Okay, so it's now attracted. It becomes a temporary magnet and is attracted to the permanent magnet. Why? Because it has opposite poles. Okay. Hmm. Iron bar is temporary magnet. Yeah. Ball P, Q, and R. P, Q, and R. What are the charges on Q and R and why? What are the charges on Q and R and why? Definitely, uh, opposite poles means north and south. They are opposite. Same poles means south and south or north and north. Q is now negative, yes, and R is now positive, yes. Q is negative and R has to be positive. So ball P is negatively charged. State the charge on Q, it is negative, and Q is and R is positive. Explain your answer for part I. Why the charge on ball Q why is it negative? Why is it negative? Because like charges repel. Same charges repel. Like charges repel. Is this worth 2 marks? Yes, it is worth 2 marks. Like charges, 1 mark, repel, the second mark. Like charges repel. Question 10. Student investigates the electrical resistance of some components. Figure 10.1 shows an incomplete diagram of the circuit used by the student. First of all, state the name of the component Y. What is component Y? Yes, it is a thermistor. Excellent. It is a thermistor. That the student uses the circuit to measure the resistance of component Y. We need to write down and we need to draw the ammeter and the voltmeter. ammeter and the voltmeter Y to measure the resistance of component Y, measuring the resistance of component Y. So the ammeter would be in series. The ammeter has to be in this position, and the voltmeter has to be parallel to Y. Can I draw it above Y? Yes, you can draw it above Y. Okay. Figure 10.2 shows two resistors A and B. State the value for their combined resistance if they are in series. If they're in series, the combined resistance would be 5 plus 7, which is 12 ohms. Yes. 5 plus 7, which is 12 ohms, because they are in series. What happens if they are now connected in parallel? If they're connected in parallel, what happens to the total resistance? Total resistance, yes, thank you, less than 5. Less than the least resistor. Okay? Less than 5. Yes, thank you. Less than 5. Less than A, less than the least resistor. Okay? Okay. Teacher uses a power supply in a metal case. The circuit for the power supply includes a fuse. Can I draw the fuse? Yes, I can draw the fuse. It's a resistor. It's like a resistor, but the wire is passing through the fuse. The wire is passing through a fuse. Explain that you have something called the earthing. Okay, I'm earthing the metal case. Okay, what is this earth wire? What is this ground wire? Okay, it's a simple wire. Okay, which is literally connected to the ground. It's a wire connected to the earth. Now, how does this wire protect the teacher? How does this wire protect the teacher? In circuits, okay, in circuits we have two main hazards. What are the two main hazards? Overheating, which is protected by the fuse, because it cuts off the circuit, it cuts off the current when the current increases. Okay, and the second one, okay, the second hazard is being electrocuted as an electric shock. This is the second hazard. How can we protect ourselves from the electric shock using this earth wire? Using this earth wire. What does this earth wire do? What does it do? If any excess current or any excess electrons, this is a metal wire. Okay, let me draw it for you. Okay, don't draw this. Okay, this is a metal case. For example, this is a dishwasher, or whatever. This is a dishwasher. Okay, this dishwasher has a metal case. It has a metal case, which is a good conductor of electricity. It has a metal case which is a good conductor of electricity. Good conductors of electricity, it has free moving electrons. So what happens if the live wire touches, what happens if the live wire touches this metal case? What will happen? We might get electrocuted. You might get electrocuted. So what does this earthing do? Okay, what does how do we connect this earth wire? It's simply a wire connected to the earth. Okay, it's a wire connected to the earth. If you have any excess electrons, okay, it allows the electrons to flow, or allows the current, okay, allows the current to flow to the earth, okay, to the earth or to the ground. What is a metal case? A metal, يعني, like the refrigerator, for example, or the washing machine, or whatever, a microwave. Okay, it has a metal casing. It has a metal. يعني, it's surrounded by a metal surface. Okay, which is a good conductor of electricity. Okay, so as it is earthed, this earth wire, what does it do? It allows the current to flow to the earth. Okay, it allows the current to flow to the earth. Why? And then we can say that how the earthing protects the teacher. You can also talk about the fuse, for example. If you want to, you can talk about the fuse in this question. Okay, you can talk about this fuse in this question. Okay, for this question, we can say that the fuse also. We can say that the fuse also protects. Okay, also protects the who's using this, the teacher. Okay. Okay, it protects the teacher from high currents by melting. By melting. Okay. Um. Anyway, anyway, moving on. Moving on to B. Moving on to B. The power supply circuit. Okay, moving on to B. Yep. The power supply to the circuit includes a transformer. Okay, includes a transformer. The input voltage is 240 volts. There are 960 turns. Okay, 960 turns on the input coil. Okay. Um, Calculate the output voltage of the transformer. Can I find the output voltage of this transformer? Yes, I can find the output voltage of the transformer. How can you, which equation should I use? I should use the equation Vp over Np equals Vs over Ns. Vp over Np equals Vs over Ns. 240 volts over Np, 960 turns on the input coil, equals Vs, which is the output voltage, over NS64. All you need to do is cross multiply, صح? Cross multiplication. So basically 64 times 240 ah, over 960, which is around 16 volts. Okay, around 16 volts. Okay. Radioactive sources emit alpha, beta, and gamma radiations. State which of these types can pass through paper. Which of these radiations can pass through paper? Can alpha pass through paper? No. Beta, yes. Gamma, yes. That's it. So beta and gamma. Beta and gamma radiations can only pass through paper. Can I find the number of neutrons? Yes, I can find the number of neutrons. 137 minus 56, which is what? 81. 81. An isotope of barium 137 has a half-life of 3 minutes. A radioactive source contains 36 milligrams of this isotope. Calculate the mass of the isotope that remains in the source after 9 minutes. After 9 minutes. It has a half-life of what? Of 3 minutes. And I need to find the remaining, okay, the remaining mass after 9 minutes. So basically, I need to find how many half-lives. How many half-lives will happen. 9 divided by 3 is 3 half-lives. What do I mean by 3 half-lives? What do I mean by 3 half-lives? Yani divide, okay, by 2. How many times? 3 times. Divide by 2 how many times, Ashab? Huh? 3 times. Divide by 2 how many times? 3 times. Okay, what is the number that I will divide by 2? What is that number? 300, 237? Well, 137? No, not 137. What is the number? 36. So you need to divide by 36 divided by 2 is 36 divided by 2 is 18. Divide by 2 again is 9. Divide by 2 again is 4.5. So the remaining mass after 9 minutes is 4.5 milligrams. What did I do? I divided by 3. So divided by 2. How many times? Divided by 2. 3 times. Why? Because in 9 minutes you have 3 half-lives. You have 3 minutes. You have 3 minutes. Okay? Where does this mass go? It is transformed into other elements. So I'm asking about the mass of this source, the mass of barium 137. How much barium 137 is remaining after 9 minutes? Okay, the remaining mass isn't destroyed. No, it's transformed into other elements, or it could be transferred into some other energy. Okay. Um, طيب, can he ask me about the time, not the mass? Yes, he can ask you about the time if he gave you the final mass. Okay, why not divide 137? Because this is the isotope. We do not divide the isotope. We only divide the mass or the initial count rate. The initial count rate or the mass. Okay. Um, okay, that's good.